Welcome to AD Academy. The main motto of this channel is AI for Aam Janta. My name is Dr. Ayan Debnath. I am an IIT Delhi alumni and Fulbright Research Scholar at Harvard University. I have total 9+ years of experience in the field of artificial intelligence, deep learning, machine learning, NLP, generative AI. Let's watch this video. Welcome to my metaverse. Now I will explain the decoder part. Before that, we should also understand that during training we are giving inputs as English sentences to the encoder and French sentences to the decoder. English sentences to encoder and the actual converted French sentences to the decoder. Here the example I have given is I am a boy. Then this I am a boy will have a French version to it. That French version we are giving as an input to the decoder. So I am a boy, it is in English, and this is given as an input to the encoder, and the French version of it, which is actually the ground truth, by which, or ground truth is also known as annotations, by which we are training our models. So that French converted sentences is given as an input to the decoder, and this is only taking place during the training. So during training we are giving both English and the French version of all the sentences to the encoder and to the decoder. So similarly, the French sentences first of all has been converted into different kind of numbers, or known as the token IDs. And then these token IDs are being converted into different kinds of vector spaces, which is known as embeddings. This is contextual embedding, and we have added also positional embeddings to those contextual embeddings of those French vectors. Then this has been passed to the decoder, so it also has a self-attention layer to it, which is self-attention, or you can say multi-headed self-attention layer. Now this has been passed to another layer of self-attention, and this context vector, let me write it in the red format, this context vector is also added to it. So here the actual conversion taking place. So in this second layer of self-attention, what we have the context vector, which is actually was in English. These context vector are being added with the French vector or French embedding, and here the actual conversion taking place, and then it goes to the feed forward network. There is one feed forward network. I will go in details of all these things in another video. Now I am giving an overview, and then it goes as an output, and here there is a linear layer. What does this linear layer does? Let me tell you in details. Let me rub this portion. Now concentrate on this portion, what is happening here. So once we are getting the output from the decoder, so there is a linear layer. What it does, it converts all the vectors to all possible words in French dictionary. So in French dictionary, whatever the possible words are there, it converts into this, and whatever words are coming from this encoder, it will be there. Few of the things will be there, so few of the things will have some value and few of the other things will not have value, and these things has been taken as an input to Softmax. And what Softmax is doing, Softmax is giving some conditional probability to these values. It is giving conditional probability to the words. So in simple language, the output of the decoder will be a vector which is passed to the linear layer of it. Here is a linear layer which is actually flattening all the words into a vector, and here, say here in English we are passing I am a boy. So corresponding some French words will be here, as I am mentioning here by tick marks, and all other places will have zero values, and this will go to the softmax. And what softmax will do, softmax will give you a conditional probability where for each of the words there are some probability values. Probability values are always ranging from 0 to 1. So if some values are in the range of 0.7, then there is a higher likelihood that that value will come as an output. And if some words is having lower values like 0.03, then there is a very less likelihood that that value or that word will come as an output. So those values which are having higher, that will come here. And as a result we have a conversion of the French value of I am a boy to some French word. And this conditional probability is actually based on the concepts which we have learned earlier in class 11-12. P, probability of P given x1, x2, x3 or x4 has occurred. So here in, say, let's for an example, say there is a sentence and here I have words, say I am a, then what word will come? Or maybe say I am mentioning that I am good, then what will be the next word will come? So this I is x1, am is x2, a is x3, good is x4. So what will be the next word? What will be the x5? This is based on the conditional probability. So conditional probability is mentioned, and probability of y given if this has already occurred, then what will be the probability, and whichever word will have higher probability, that word will be the next word here. So that is being considered in this softmax function, and thus we see that we are getting those French word which is having higher probability values, and in this way we convert the English to French or any language translation we do with the help of transformer. Language translation is not an only application. Transformer has wide range of application, but for an example I am showing you with respect to machine translation or language translation.